start with the exit ticket from lesson 7. The main reason I want to start with it is because I've seen some questions like this on Zern about mowing lawns and things. And so I think it's a good one to practice together. So let me read it.
Yeah, we're doing the exit ticket. Sorry.
Yep. So let me read this problem. It says Mr. Pham mowed 2/7 of his lawn. His son mowed 1/4 of it. Who mowed the most? How much of the lawn still needs to be mowed? Okay, before I draw the tape diagram, which one do you think is more, 1/4 or 2/7?
1/4.
I know. So we're going to see if that's really the case when we finish solving this, okay? So the first thing I want to do is start by organizing my information on a tape diagram. So I don't know if you remember this yesterday, but about half as long as your words are, make a tape diagram, okay? Leave yourself room to write above it. So taking a look at how to organize this, I've got Mr. Pham, I've got his son, and I've got how much of the lawn still needs to be mowed. So how many sections does my tape diagram need? 3. And it doesn't matter what size they are, just draw your lines.
Don't they each one up top?
So we've got 2/7. That's Mr. Pham, right? And then his son was 1/4. And then I call it left. Do you remember that from yesterday? Yeah. So how much is left? That's our main question. Besides, who mowed the most? We'll figure that out in a minute. So I need 1 hole here. What's it going to be?
1. Oh, 2.
It's going to be 1 whole lawn, right?
Oh, yeah.
So 1 lawn is what they're mowing. Could be a front yard and a backyard, couldn't it? But it's all the same lawn, okay? Now, do you remember yesterday I gave you an example of a problem that is the same as this, but it was with whole numbers, not fractions? And I said, what number goes in the box? 5. Okay? How'd you get that?
Because 16 plus 4.
We added 16 plus 4 to get 20, right? And then we automatically know that 20 plus 5 is 25. Or we might have done 25 minus 20 equals 5, okay? So the same strategy still applies. We're going to add those 2 together and subtract from the total. What's the total today?
28.
1 whole, okay? So we'll add these together, subtract from the whole. So 2/7 plus 1/4. And Isaiah already said that the common denominator is 28. Okay, and in preparation for your assessment, let's put these on area models. Okay, so when I add fractions together, I need to write them below before I draw the lines. And this was all the way back on lesson 3. Okay, so what's my first denominator?
7.
So I need 6 lines. And how many are shaded?
2.
2. And my second denominator?
1/4.
So how many lines do I need?
3.
3. Good. Then separate my sevenths into fourths and my fourths into sevenths. And then you just count.
Mrs. Lewis?
Now you want to know something really cool? Are you to this point? Okay. All right, go ahead and get to that point. So there's an easy way to get the numerators. Have you already figured it out? 4 times 2 equals 8.
Oh,
7 times 1 equals 7.
that's cool.
That's really cool, isn't it? Yeah. So eventually we're going to do it like that. So 4 times 2 equals 8. And 7 times 1 equals 7. For now, though, your grade is, can you draw this diagram? Okay? And so my answer here is
1528.
15/28. Is that my answer to the whole problem?
No.
No. How do I figure out my answer to the whole problem? Because now I know that these two added together is 15/28.
28 minus 15.
So 1 whole minus 15/28. Is that 13?
Yeah.
So 13/28 is the answer to the question. How much of the lawn is left to mow?
1528.
15/28. Which was larger? No, 13/28. Which was larger, 2/7 or 1/4?
1/4.
Really?
2/7.
Because this is 8/28 and that one's 7/28. So which one was larger?
2/7.
I was wrong. I figured it would be 1/4.
So
Because 2
Okay.
is greater than 1.
But it's not always the case, though. That just turned out to be that. It's 1/28 more. So that's what kind of problem you're going to solve for grade today, okay?
A lot of numbers changed.
So, okay, but our tape diagram is probably going to be similar, so let's see, okay? Christine baked a pumpkin pie. She ate 1/6 of the pie. Her brother ate 1/3 of it and gave the leftovers to his friends. What fraction of the pie did he give to his friends? So, tape diagram. The total is 1 pie. Okay, so we have Christine, her brother, and the leftovers. How many parts do we need in our tape diagram?
3.
4.
3.
3. Very good. So we've got Christine, and it doesn't matter the size, we're just organizing information. We've got her brother, and we've got what was left. So how much did Christine eat? 1/6. How much did her brother eat?
1/3.
And how much was left? Okay, so same type of problem.
What different?
So we'll add these two together and subtract from the whole.
That equals 10.
Common denominator for 6 and 3.
18.
18. 2 boxes.
Can I write it on the back because I'm losing space?
Of course you can. So this is the same type of problem. You're getting 2 practices before I grade the
Wait.
problem 2 down there.
Can we do the easy way? Where you just go.
Can you stop asking that? I'm not the one that makes these rules, okay? But I'm going to follow them until after this assessment. And I've said many times, after this assessment, you can do it the easy way, okay? But this assessment requires that you are able to draw the diagrams. So we're going to continue to practice that. This is the last time we practice it.
So 5 lines or 6 lines?
Well, 1, 2, 3, 4, 5 is what I drew. Is that right?
Yeah.
Yeah.
Just asking.
And 3. Shading 1 again?
What?
Make sure you shade before you draw all the lines. That's a mistake that happens over and over again. Right, 19. Okay, pretty simple problem, wasn't it? So what we figured out is this is 9/18 right here. Okay? We still don't know what's left because we still have to subtract from the whole. What's the whole?
18.
So 18/18 minus 9/18 equals 9/18, which can be simplified.
Into 1/2.
What question should we ask ourselves?
Is 9 half of?
Is 9 half of 18?
Yeah.
Yes.
So there's your answer. Half the pie's left for the friends. Okay.
A lot.
All right, so we're gonna go down to number 2. We're gonna get it set up. You're gonna solve it for grade. Okay? I think that's Lang, but I don't know. Went to the bookstore. He spent 1/3 of his money on a pen and 4/7 of it on books. What fraction of his money did he have left? Is this the same type of tape diagram? Yes, it is. So the total here, when you go somewhere to buy something, is all your money, right? So we could call it one wallet, or we could just say one whole, but it's all the money. So how many sections again?
3.
3. We've got pens and books, and what is left over? So pens are 1/3 and books are 4/7. Okay? So here's what you're going to do. When you get this much written down, I want you to finish the problem like we just did the other two, okay? So you'll write your addition problem, and then that will be the answer to this, these two, and then you have to subtract it from the whole, okay? Are there any questions? All right, so do that. Let's look at problem 3. It's different. So I'm going to read it, and then we'll see what to do about tape diagrams. Tiffany bought 2/5 kilograms of cherries. Linda bought 1/10 kilogram of cherries less than Tiffany. How many kilograms of cherries did they buy altogether?
It's a kilogram.
So the first thing we have to figure out is how to put this on a tape diagram. And on this one, you're going to need 2 tape diagrams that are the same size. One for Tiffany, one for Linda. So go ahead and draw 2 tape diagrams, and I'm on problem number 3. And line them up right underneath each other, but give yourself room to write on top if you need to, okay? So you got that much done? Just go down and do it on number 4 since you didn't do it right. Okay, there you go. So leave a space between. Okay, so I'm going to read it again, and then you're going to help me figure out what to put on these two. One for Tiffany, one for Linda. Okay? Tiffany bought 2/5 kilograms of cherries. Linda bought 1/10 kilogram of cherries less than Tiffany. How many kilograms of cherries did they buy altogether? So do we know what Tiffany bought? 2/5. Okay. Do we know what Linda bought?
No.
Sort of.
1/10.
1/10 what?
Less.
So I'm going to put a dotted line there. So this right here will represent 1/10. So Linda's total, we don't know. Okay? So we know it's 1/10 less than Tiffany's, but we don't know what it is. Then the question says, how many kilograms did they buy altogether? So those are our 2 steps. Okay? First thing we have to do is figure out the question mark. Then we have to add the question mark with Tiffany's total. So what is the question mark? How do I do the question mark? Katie, how would I do this? Am I going to add these 2 together? I'm trying to figure out this.
You're going to subtract it.
I'm going to subtract it. So I'm going to do 2/5 minus 1/10. And I'll let you solve this numerically. So before we go any further, 50 is way too large of a denominator for my comfort
When
zone.
we go least common factor.
How about least common multiple?
Yeah, least
Okay, so yesterday we did that. So we'll do 5 and 10. Count by 5s. Oh, I'm done. What's my least common multiple? 10. So I'm going to make both of those be 10, and you'll get better at this. Xavier, I want you to focus. So if you can't sit still on that one, find a different seat. And get that highlighter out of your mouth. Okay, so this is how I figure out the denominators. Are you ready? I mean the numerators, sorry. I know that 10 times 1 is 10. I'm going to change the color. So I'll multiply the top times 1 too, and that ends up being 1. 5 times what equals 10? What?
2.
So what's 2 times 2?
4. So it'd be
Okay. 4/10. So you can't do the multiply across thing on this. It won't work. That only works when you pick 50 as a common denominator, and we're not going to pick one that high. So 4 minus 1 equals?
3. 3/10.
Okay, but that's only half of my problem. What's the other half?
We have to.
You gotta subtract that from.
You're good. You're getting closer. It says how many cherries did they buy altogether?
Oh, you gotta add it.
Add it to. So this right here is 3/10, isn't it?
Yeah.
Okay. So we know that, and I could have even crossed that off because hers is less, isn't it? So we're going to add 3/10 plus 2/5. And we're going to do it the same way.
But we already know what.
We already know that the common denominator will be what? 10, because we just figured that out. So we just have to figure out the numerators. Okay? So this is where I get a different color. So 10 times 1 equals 10. So 3 times 1 equals 3. 5 times 2 equals 10. So 2 times 2 equals 4. So my answer is
7/10.
7/10. Altogether, they bought 7/10 kilograms of cherries. That was fun, wasn't it? Let's do another one. We're going to do number 5. And it'll be the last one. This one's similar because we've got 2 things here. We've got ribbon A and ribbon B. So let me go ahead and read it. Ribbon A is 1/3 meter long. What do you think it is talking about? It is shorter than ribbon B.
The ribbon?
Which ribbon?
The ribbon.
Ribbon A, okay? So A is shorter than B. What is the total length of the two ribbons? So again, I'm going to make two tape diagrams that are the same length. And I know that A is 1/3 meter long. I also know that A is shorter than B. So B is going to be longer. ... You don't have to make a dotted line. I just do that to show that I added on to it, okay? So how much longer is ribbon B?
1/10. No, 2/5.
2/5 longer. And the question says, how long are they all together? So how do I figure out all together?
Minus. No.
I'm going to add.
Oh, yeah.
So to figure out all of these, I know that B is the same as A plus 2/5, right? So how long is B?
It's,
How long is this part of B?
we don't know yet.
Yeah, we do. It's the exact same as A,
Oh, yeah.
Oh, 1/5.
okay? So we're going to add 1/3 plus 1/3 plus 2/5. Can we add any of that in our heads? We don't. 2/3. So we could do 1/3 plus 1/3 is 2/3. So I think I'll do it down here. 2/3 plus 2/5. Want to solve it numerically?
Yes.
Okay, let's do it with the parentheses. Same thing we just did, but a little more organized. Okay, so what's my common denominator? 15. Okay, did you get to this point?
Miss Lewis,
Yes?
you have
That scared me.
Okay, so here's what I think. 3 times something equals 15.
5.
Okay? So I'll multiply the numerator and the denominator by 5. So what's 2 times 5, Katie?
10.
Thanks. 5 times something equals 15?
6.
3.
And what equals 6?
Am I done, Riley?
No.
I'm going to ask Riley this question because he's working on this lesson. So this is improper, isn't it? I'm going to have a mixed number for an answer. How am I going to figure that out?
you find out if the top number is bigger than the lower number.
Good. Okay, so what would 1 whole be?
15/15
15 fifteenths plus
1.
1 15th equals 1 and 1/15. Now, am I okay with you skipping this step right here? Yes, I am. I just teach that to you because of Zern. Okay? Because that's the way they do it on Zern.